Hi, Roland is the name, networking is the game. Once again, welcome to my YouTube channel. We're learning the A to Z of network devices configuration, verification, and troubleshooting is guaranteed, as well as tips and tricks on how to manipulate and maneuver your network devices. In today's tutorial, my organization, PSL.com, just acquired a new router and my boss has instructed me to configure and connect this router to our existing network. Okay, he's expecting new employees. Okay, in addition, he has asked me to add PCs to each of these routers that we have on our network. Okay, now recall that from the last class, after assigning IP addresses to these interfaces on these routers, we're unable to communicate across the local LAN. We could only communicate within the network. In other words, what I'm trying to say is that devices can only communicate with one another when they have interfaces connected on the same network. So routers can only see directly connected networks by default. For a router to see a network that is not directly connected to it, for example, for this router, this Rome router, to be able to communicate with this router I'm about to configure now, Madrid, that will be the host name, it means that I need to configure something called IP routing. Now, IP routing allows devices to communicate across multiple networks, even remote, far distance networks. We have two categories of IP routing. We have the static routing and the dynamic routing. Now, with the dynamic routing, the routers can automatically communicate with themselves and learn about networks that are not directly connected to them, using or by exchanging what we call routing update packets, which we'll see in subsequent classes. Okay, but for static routing, you the network administrator need to manually tell each and every router on your network how to get across to a network that is not directly connected to it. It's a little bit stressful. Okay, also, when there's a change in the network topology, you need to tell the router, each router, about this change. Probably if a new network is added or an existing network has been removed. Okay, so since we are connecting this router to this network, we need to establish routing. In this video, we shall focus on static routing. Okay, now at the end of this video, you learn how to statically inform a router about a remote network, how to verify that your static route is working by performing end-to-end testing, by verifying the IP routing table, and how to assign IP addresses to devices or PCs, okay, and then make them part of the network. Without further ado, let's begin. Now on this router, as usual, to configure this router, I need to connect my PC and connect to the router via a console cable. Okay, so I'll connect to the console cable and drag it to this PC. Okay, so I can access this router via the console. Now, I need to connect serial ports here, a serial module, because by default, as you can see, this router does not have a serial module. So as usual, I'll log into this router, go to physical. Oh, okay, let me change this router. I don't want this router. Okay, I prefer to use this router since this is the one we've been using previous videos, 2811 series router. Okay, so I'll connect my console to it. Okay, now I'll log into this router and select my serial interface or serial module. I need to switch off the router, power off the router, and connect as usual, just like what we did in my previous video. Guess you can still remember. Okay, so I'll power off and connect and power it back on. Okay, now I'll log into the router through the PC and you'll definitely see the router booting. Okay, now I'll give this router, I'll answer no. I want to give it a host name. Okay, my boss asked me to name it Madrid. Okay, now I also need to give this router interface address. Okay, so there's no serial interface here. It's only one serial interface we are having here, but we need to connect another serial interface, so we need to add a module here as well. So similarly, I'll switch off and then add my serial module, a second one here, and power it on again. Okay, and log into the router. Okay, now I'll need to go and give that IP address on the router. Now let me do this. We're giving this interface an address of 192, or we've given it an address of 192.168.10.0 slash what 30, if you can recall from the previous class. And so I'll connect this router as well. Okay, to serial 0/2, drag it to this router interface serial 0/3/0. I'll log into this router and give it an IP address as well. Let me do this here as well so that we'll be able to identify. Okay, so I'm going to give this 192.168.20.0/30. Okay, oh, when we powered off this router, the IP address we gave went off initially. Okay, so I need to give it an IP address on this interface as well. Okay, now I'll log into this router. Before we do that, let's connect the PCs, because like I said, my boss asked me to connect PCs to these routers as well, end user devices, and he said the guy connecting to room, I should give it a name, Julio. So Julio is connecting to the room router. Okay, and to this router, you say Jones is connecting to the London router. So Jones. Okay, then Hernandez is connecting to this router. Okay, so now in connecting these PCs to the router, I want to make it clear that this connection is going to be different from what we have here. As you can see, I connected this PC to this router via the fast Ethernet cable, and I used crossover cable. That's different from what we did here using console cable. Now the sole aim of this connection was basically to allow access to this router to verify and troubleshoot and configure. Okay, that's why we connect through the console. But using the fast Ethernet, this is now an end user device. There's somebody connected there who needs to be part of the network, and so we need to give this host an IP address as well. And the connection used in such cases between like devices, a router and a PC, is what? Crossover cable. So take note. So do the same thing here. Okay, this to this, likewise this. Okay, now the next step is to go into this router and configure it. Okay, like I said, the IP address, I need to give an IP address to this router. Now the password we used here initially, if you recall, we used Cisco. Okay, enable, and for this enable password we used class. Recall from the previous class. Okay, now I need to go into interface serial 0/3/0 and give it an IP address 192.168.10.2 255.255.255.252. Am I supposed to do clock rate there? Let me confirm. No, I'm supposed to do it on serial 0/2. Okay, so in this case, no shutdown, exit. Okay, I go to interface serial 0/2/0. That's the next interface, and I'll give it an IP address of 20.1. Okay, 20.1. Okay, in this case I need to enter the clock rate command. No shutdown, exit. Okay, now I need to give this an IP address as well. Like I said, let me say we are giving this an IP address from this 172.168.2.0/SU/28. Okay, likewise here, let's say we are giving it an IP address in this from this network 172.168.1.0/28. Okay, this 172.168.3.0/28. Okay, good. So we need to enter this interface. I need to confirm the interface, fast Ethernet 0/0, I suppose. Yeah, so interface fast Ethernet 0/0, IP address 172.1.255.255.255.240. No shutdown. You don't give clock rate on fast Ethernet interface. Take note. Okay, exit. Exit. Good. So I'll save. Now I can save by typing right, like I said from the previous class, in the privilege exec mode. But whenever you are on a mode that is different from the privileged exec mode and you want to enter a command that is normally entered at the privileged exec mode, you can type do at the front of the command, just like what I've done here. Take note, very important tip. Okay, good. Now let me configure this as well. Okay, I need to log into this router as usual and give it an IP address. First and foremost, password Cisco. Okay, class as usual. Okay, we go to the global configuration mode. We go to interface fast ethernet 0/0. We enter our IP address 172.16.1.1, 255.255.255.240 as a subnet mask. No shutdown. Exit. We save. Okay, now on the last router, oh, my boss is already calling me. We are running out of time because I'm explaining, I'm taking too long, you know. You said the employees are already waiting. Okay, I'll get back to him. Okay, now okay, on the Madrid router, enable. Okay, have we given IP address on the Syrian? No. So interface Syria 0/3/0, interface Syria 0/3/0, IP address 192.168.20.2. If I'm not mistaken, 255.255.255.252. No shutdown. Exit. Likewise, interface fast ethernet 0/0, IP address 192.160, sorry, IP address 172.16.3.1, 255.255.255.240. Okay, no shutdown. Exit. We do right. Okay, now that being said, we are done with this configuration. But however, have we configured this IP address? We've entered cloud. Okay, good. Now the next thing we're about to do is to test our configuration. Like I said, by default this host can only ping this interface on this router. It can't ping this other router that is not connected to the same network with it. Let's confirm that. So from this Julio, let's see if Julio can ping 172.16.1.1. However, before we go further, we need to give IP addresses to the host. I've forgotten. Okay, so we enter each host. Like I said, this is where you give IP addresses to the host. IP configuration. On this host, we'll give it IP address from the same network as the interface on the router connecting it, which is the fast Ethernet interface. Remember, we gave this router 172.168.2.1. So we'll give this host possibly 172.16.2.2. As you can see, that puts them in the same network. If you are not conversant with subnetting, you check my video on subnetting. Very, very interesting video. Okay, 172.16.1.1.2. Now recall that the subnet mask in this case is 255.255.255.240. 40. Okay, now the default gateway, this is what I want to say about the default gateway. Now the default gateway, for those that are new to this, it's actually telling the devices on the LAN that this is your gate. In case you want to send packets or traffic outside the local area network, you have to pass through this gate. Now, if you don't tell a device where the gate is, that device might not be able to send packets outside the LAN. So the gate for this PC, for example, is the interface IP address of the router. The router is standing as the gate in this case. So the IP address on that interface connecting to the PC is its gate, not this interface. This interface is also on that router, but this interface is connecting to a different network. So we use this IP address of this fast Ethernet interface. Very important, which is what? 172.16.1.1. Okay, so we apply the same technique here. Okay, so the IP address here is going to be 172.16.2.2. The subnet mask, the same, 255.240. Okay, now the gateway address is going to be 172.16.2.1. okay, now we log into this device as well and do something similar. So on Hernandez's route and desktop, we can come in here and give the IP address of 172.16.3.2, 255.255.255.24, and the gate will be 172.16.3.1. Good. So we can now verify or confirm that this device can only, or devices can only see directly connected networks and not networks that are not directly connected to them by default. And then we'll now establish our static route to ensure end-to-end connectivity. That's our next process. However, before we continue, let's pause for a while. Click on the subscribe button so you'll get notified on my subsequent videos. Okay, thank you. Let's continue. Good. So I'll come to this PC and ping this interface on the router, which is its gateway. So ping 172.16.1.1. You can see it's telling me reply from the device I pinged. 4 replies. Wonderful. You can see 0 packet loss, 4 sent, 4 received. So that ping was successful. However, let me try to ping across to 192.168.10.2, the other router's IP address. Okay, 192.168.10.2 to tell me request timeout. Okay, you can see request timeout. That's to tell me that what I requested for, the packets I intended to send across, timed out after the default time. The default time by default is about 2 seconds or thereabout. Okay, so no reply. We can also try to ping from here to Hernandez, because my boss instructed me that Julio must communicate with Hernandez. So Hernandez is sitting at an IP address of 172.16.3.2. Let's try that. Okay, 172.16.3.2. Obviously destination host unreachable. Okay, Now, after we finish the static routing configuration, we should be able to achieve end-to-end pinging. Likewise, if I ping from this router, let's try it. I can only ping this IP address, but not the Madrid router. Let me change this to Madrid. Okay, so not the Madrid router. Good. Let's try it. So I'll log into this router, go to the privilege mode. So I'll ping 192.168, the directly connected interface on the other router. You can see that's going, but let me try to ping across to the other router, the Madrid router. You can see it's not going. So let's configure our static routing. Now, in configuring the static routing, what we intend to achieve is that we'll enter each router. For example, we'll enter the Rome router. Now, by default, the Rome router can see directly connected networks. So this Rome router can ping this by default and can ping this host by default. So I'm not going to establish static route to these devices. Rather, I'll establish the static route to a remote network. So to this network that is not directly connected to the Rome router and this network. So two static route statements from Rome router. From London router can see 10.0 network and 20.0 network, but it can't by default see 172.16.1.0 nor 172.16.3.0 networks. So we need to establish static route from this to those networks. Okay, we'll do the same thing here. Two static route statements as well, to this 10.0 and this one, but not to this and this. Okay, good. So you can see how stressful it is. This small network requires two static route statements each on these routers. Imagine the bigger the network, or the more the routers, the more the static route statements. That's why we say static route is stressful. Good. So let's do that. So now how do we do that? You go to the global configuration mode and start the command by entering IP route. Now the command syntax is IP route destination network address. Okay, so IP route destination network address or remote network address, the subnet mask of that remote network. Then you can either use the outgoing interface syntax, outgoing interface type, or the next hop IP address. Okay, so next hop, let's use the outgoing interface type first. IP route. So from this router, I intend to establish static route statement first to this 192.168.20.0 network. So that's exactly what I'm about to do now. 192.168.20.0. Okay, the subnet mask 255.255.255.252. Now the outgoing interface type towards that direction from this router is serial 0/3/0, as you can see there. So that's what I'll type there. The command syntax says we can either use that outgoing interface type or next hop address, not both of them. Okay, so let me do or establish the static route from this router to the other network, non-directly connected, 172.16.3.0, and I'll use the other syntax in this case so that you understand what I mean by next hop address. Now the next hop address is actually the next router's interface address. Hop is a routing device, for example a router. So next hop IP address, next router from the router you are on. I'm on this router, so the next hop is gonna IP address is gonna be 192.168.10.2, not this one. Remember, this IP address is also on this router, but it's not the immediate next hop address. So take note. So 10.2 is going to be my next hop address. So I'll come here, IP route to that 172.16.3.0 network. Okay. 240 is the subnet mask 3.0 network. Okay, 255.255.255.240. Now the next hop address is gonna be 192.168.10.2, and I'm done with this router. So I'll save my configuration. Then I'll go to this router. This router requires two static route statements to this network and this network that are not directly connected. So to 172.16.1.0, my outgoing interface 0/3/0. So let's do that. Okay. Configure terminal, IP route 172.16.1.0 255.255.255.240 serial 0/3/0. Okay, serial 0. So IP route 172.16.1.0 255. Okay, now I have to establish another static route from this router, the same router, to this, with this serial 0/2/0 as the outgoing interface towards that direction. Take note, very important. So I'll use my shortcut key to recall the command. I taught you that in the first class. To make it faster, my boss is already waiting for me. I'm taking too long to finish this configuration. Okay, so 255.255.255.240. Now we edit this to serial 0/2/0. Then we save, do right. Okay, now we go into the third router. On this router, we'll establish to this network and this network using this as the outgoing interface. Like I said, you can equally use the next hop IP address, but since we are running short of time, that's why I'm trying to just do the one that is faster. Okay, I'm going with the faster option. Okay, so IP route 192.168.10.0 255.255.255.252 serial 0/3/0. Repeat the same thing, but we have to edit the the same outgoing interface, but we have to edit this to 240, recall, because we are establishing it to 172, the first network, 172.16.1.0. Do right. Okay, now we are done. Okay, so we need to verify. Okay, so in verifying, I'll still come on. Now, if we can ping, if Julio can ping Hernandez, that's what my boss intends to achieve or wants us to achieve. Once Julio can ping Hernandez, it means every other connectivity here is working. Okay, so there will be no point for us to go into a device and ping. So let's ping end to end. So I'll come here and ping Hernandez. Hernandez's IP address is 172.16.3.2. So let's do that. Initially, we're not able to ping it, okay? But after the configuration, we should be able to ping it, as you're seeing now. The first one timed out. There's a reason for that, which I'll tell you later. But if I repeat that command, it will not time out again. Okay, so you can see the pinging. I'm pinging from the first router. Julio's router that is sitting in Rome is pinging Hernandez's router that is sitting in Madrid. Wonderful. So that's what we've ended up to achieve. Okay, now before we conclude, let me show you what the routing table looks like. Okay, so how do we verify the routing table? Now, if you log into this router, for example, the routing table is the map that the router uses to make its decision. It's just like you using your Google map, you know, to make decision on how to navigate or locate your destination. So each router must keep a routing table. Okay, so after configuring our static route, each router has already got a routing table. So on this router's routing table, I should be able to see these two networks as directly connected, while I'll see this one and this one as land via static route. What do I mean? Now let's go to this router. Now the command syntax used to verify our routing table is show IP route. Show IP route from the privileged exec mode, not from the global configuration mode. Now let me give you a clue. Every command that begins with show, it's performed at the privileged mode. Every command that begins with copy, show, erase, they're all done at the privileged mode. Take note. Wonderful clue. Nobody's gonna give you that clue apart from me. Okay, now show IP route. Now you can see this is my routing table. Now let me tell you how to study the routing table. Very important, as subsequent and advanced classes will be discussing much more of this. Okay, now the codes are there. Now these are the codes. C is for connected routes, like I said. S is for static, which are the two codes we'll be focused on today or right now. Likewise, subsequent classes will see what R means, EIGRP and co. Okay, those are routing protocols. Now, so from this router, you can see it's telling me that 172.16.1.0 is directly connected through serial 0/3/0. This is what it means. I'm on this router. It's telling me that this network is directly connected through this interface, as you can see. Okay, now if I view the routing table again, it's telling me that 172.16.2.0 is directly connected. So 172.16, this is directly connected, this one. Okay, it's also telling me that 172.16.1.0 is directly connected to serial 0/3/0, and you can see static there. Okay, now the reason why it's telling me that 172.16.1.0 is directly connected is because of the fact that I used the outgoing interface, but ideally you can see it's connected through static. Had it been I used the next hop address, it will not tell me it's directly connected. Okay, So you can see it's connected through this interface, okay, and through static route. Okay, now you can see, what do I mean? 172.16.1.0, this network is learned by this router through the static route. That's why you can see the code S by its side. Likewise, 3.0 is through static. This is 3.0 through static. You can see that, in summary, all the networks that are not directly connected to the router are learned via static route. But these three are LAN via connected, as indicated by the C code, connected, S static. Now this is a very good base for troubleshooting, which we'll discuss later. I'll tell you in my subsequent classes all the necessary tips required for you to be very efficient in your troubleshooting skills, because that's what we focus on. Okay, in my training, we focus on troubleshooting skills, such that if you're preparing for your Cisco certification exams, you will not have a problem when confronted with any troubleshooting question. If you're in a production environment and you find yourself facing challenges, you know how to navigate your way through if you attend my classes or tutorials extensively. Yeah. So this is where we call it a day. As a recap, we've learned how to statically configure our routers, as you can see. So from previous classes, we had only 2 routers connected where we configured directly connected routes, or give it an IP address basically. But right now, in order to communicate across the LAN or across the local directly connected network, we need to configure static routing, for example, which we've just done. We've also verified the static routing by pinging from one end to the other. And finally, we've also taken a look at what the routing table looks like. Okay, and we also learned how to give IP addresses to hosts to make them part of the network. Very important skills. Okay, hope you had a wonderful time as you embark on the superb journey to unlimited treasures. If so, kindly subscribe and drop your comments below. In addition, for further intensive training and consultation, chat me up via the email provided. Thank you once again, and arrivederci.